I don't have them reported here, but yes, Pat has that. And then we also did something with light traps because we missed the original sampling on our by picking up the fish redds. We looked at light trapping, so we put in a total of 10 light traps, ran them for an hour to an hour and a half, 10 each in Mud River Reservoir and 10 in Plum Orchard, and looked at and divided those out by species, or at least bluegills versus everything else, and looked for deformities. We obviously hit Mud River Reservoir when there was a hatch, and probably hit Plum Orchard when there wasn't a hatch, but at any rate, didn't see any deformities in either one. So this was done by John Howell, John Howell and Pat Mazik in our Fish and Wildlife lab up here. So, didn't pick up anything significant there. We also looked at the bluegill size classes, and this is Plum Orchard Lake, and these are millimeters on the x-axis. So, peaking out around 50 to 60 millimeters. And then bluegills in the Mud River Reservoir is a little higher, closer to 100, 75 to 120 or so millimeters. So, I don't know what that means, but obviously they weren't midgets. So, preliminary conclusions. We're looking at the mass balance. It's underway. I'll show you some preliminary estimates I've done on that scale. We're looking at in our model for fates for selenium. One is immobilization in deep sediment, which is our expert Kevin Bree from Ecotox tells us is anything greater than 5 centimeters. Volatilization, which we'd have to solve for by subtraction at this point. Obviously circulation and biota biomagnification, and then discharge out of the lake into the lower Mud River. And also determining the major source of selenium. I think we've already got that nailed down. It is HOVET 21. So this is how we're going about the preliminary mass balance. These are just some of the calculations on slide 28. We're looking at the current selenium load. We can estimate the annual load. The reservoir is 14 years old, and since the mine has advanced toward the river at some rate, which we don't know really at this point, I just take the current rate and assume that 14 was 0 and make half of that the average rate over the entire period of 14 years. So that gives me a cumulative load, and this is crude, but gives me a cumulative load of about 1.12 tons of selenium. Should have been accumulated or actually reported to the reservoir. The reservoir discharge, on the other hand, I did the same thing there with regard to the half-life, and came up with about 0.04 tons leaving the reservoir, based on what we know so far. And then I looked at the two ways of estimating the total selenium mass in the sediments in the reservoir itself. Looking at a 306-acre area, the average sediment concentration is 0.677. And we sampled down to a depth of 20 centimeters total, but let's just say, and we didn't see any drop-off in selenium concentration, so let's just, for the sake of argument, say it's 30 centimeters before you run out of selenium. That could be 50 centimeters for all I know in some parts of the lake, but I'm just using this as a way of calculating. So you can translate that into cubic yards, give a volume of, or a density of the sediment, about 1.75, which is basically a loamy soil. And you wind up with about selenium in sediment about 0.6 tons. Now, I make these in red because we're doing some serious guessing here. But if you wrap those all together, and this is all part of the model formation that we'll hopefully get better numbers on. On 29, you have the selenium coming into the reservoir. Give that 100%. The exported selenium leaving the spillway on the reservoir is about 37% of that. So looks like about 1/3 of the selenium is just blowing through the reservoir. And the selenium in sediment, if I solve it by subtraction, in other words, that minus that, I get this, which is 0.71. If I solve it by estimating how I did in the previous slide by looking at the total surface area, the depth of and concentration of selenium in the sediments, I come out with about 0.58, which by subtraction leaves me about this residual about 0.13 tons, and neither that's volatilization or I should use 40 centimeters rather than 30 centimeters. If I use 40 centimeters, that goes to 0, for example. So at any rate, these numbers are not wildly far apart.